I'm Professor Don Reamer, and I'm the Director of Entrepreneurial Programs in the College of Engineering. I had a wonderful opportunity to participate in a sustainability activity in the Kern Entrepreneurial Education Network. It was just unbelievable the way the students performed in their presentation. Learning experiences were many. Most important of all, the students learned about failure. They also learned about what worked and maybe what didn't work. The activity was very hands-on. They recognized some of the issues and the materials and the importance of sustainability in the manufacturing process.
Students use problem-based learning to showcase how industry can address sustainability based on the project analysis. And in terms of the sustainability, we would like to focus on sustainable manufacturing, which encompasses the technical feasibility of environment responsibility, which conserve energy and natural resources, as well as safety and economical viability. And this video will showcase the sustainability module in terms of the part of manufacturing process curriculum, which we develop in the educational environment. And part of the environment, what we did, at the beginning of the semester, students identify a related project, a related product that which related to a real life situation. Since we are in automotive area, a student picked mostly the automotive related product so that they can get first-hand experience with the engineers. After selecting the product, what they did, they will talk to the industry engineers, practicing engineers, and try to understand what the design, what the manufacturing process is, so that they can see how they can address the sustainability issue. And when they know that this is the product they selected, then they try to see what is the sustainability they can address, part of their innovation or part of the design improvement or the manufacturing process improvement. And in that situation, what they did, after talking to the working engineers, they figure out different aspects in the reliability, energy conservation, or the efficiency, or the environmental issues, all those things, or recyclability. And each team developed alternative sustainable design or alternative manufacturing processes which can address the sustainability. And part of the solution, they use creative problem solving technique to develop their optimal solution, and they use different kind of quantitative technique to compare the different approaches, and based on the approaches they found the optimal solution. Faculty and working engineers were part of the evaluation process, and they provided great feedback for the project, and it was very interactive, that you will be able to see from their clips how that was the learning and some of the student interview. And it is a great experience for our student to see first-hand experience with the real product and with the real industrial environment. And this was the great thing for our student as well as the industry partner, so that they can improve the sustainability issue. So here we would like to mention sustainability should be the first, then innovation. So that's why student can see how sustainability will address in the greater society. In terms of the performance evaluation, student can choose many aspects like cost, quality, efficiency, energy, yield, reliability, or recyclability. Based on the product selection, they will figure it out which product to address. Sometimes they will say that they want to make the engine efficient, fuel efficient. Sometimes they would like to choose the material so they can use after use they can do for the recyclability. So that kind of thing they address is part of their design or part of their manufacturing process selection. Part of the process, how was the student learning? We use pre and post survey, where we have the different entrepreneurship or different sustainability outcome, we put it together. So beginning of the semester, we did the evaluation from the student, how is their learning. After doing the project, throughout the semester, we did another evaluation. Based on the comparison, we see how is their learning behavior. Part of the learning behavior, some of the area we could see that they did some improvement. Some of the area we could not see that much improvement. That there could be many other reasons, because when they're talking to industrial engineers or manufacturing engineers, they got some experience. Some of their background could be an issue. So overall, we measure in 1 to 5 scale. 1 is the lowest and 5 is the highest. That's how we do the different comparison of their pre and post survey analysis. And we provided different kind of statistical analysis. Statistically, they'll gain knowledge out of the sustainability project, so that they can address entrepreneurship and the sustainability together for their curriculum, and it would be a great experience for their career development. As part of the project selection, students identified different products related to automotive manufacturing due to the location of our university. So there are 10 projects students did throughout the 2 semesters. First project they did, I would like to talk about the brake pad. So when they found the brake pad, they would like to identify what could be the environmental issue. Like when we use the brake material particle is coming out and going to the environment, or what is the reliability, the useful life. So if they can increase the useful life, or they can reduce the dust, that's why they can improve the brake pad. So students did that kind of analysis, part of the sustainability.
The characteristics of the brake pad that we're going to look on improving are performance, such as how quickly it stops the vehicle, durability, how long the brake pad lasts. It is something that wears down over time, and also the environmental impact. Since the brake pad's wearing down, there's little metal filings and other metals that do escape into the environment.
In terms of the brake rotor, the student did similar thing for the brake rotor. They can see how frequently brake rotor is breaking down, and they would like to do the different design and manufacturing, so the life of the brake rotor would be longer. So that's why environmentally will waste less material, and it will be the cost effective. And another project student did that pinion gear for the transmission. So what they did, they are using the quenching technique, and they are wasting a lot of energy. How they can improve the energy, and that will ultimately affect the sustainability, and that was a really great project.
So the alternate approaches that we looked at were different materials, and then obviously we looked at the manufacturing processes to kind of help with the sustainability of these parts. So the different materials we looked at were like titanium. The current one, the different steel alloys is the current. Aluminum, a composite material, and then we looked at just something like stainless steel. As you can see, like the ductility for each, we want it to be low. So titanium's low, steel alloy's low, aluminum's high, and the composite material are medium. So like thermal expansion for each one is low, and then the composite materials medium. The yield strength, corrosion resistance. So each one pretty much comes out to steel alloy still being the best material being used. And with titanium, the only thing that stopped that was just the high cost of it being done. So the alternative process that we looked at.
We looked at induction hardening versus carburization. Carburization takes a long time. It can take up to 8 hours. Their process takes up about 8 hours. It depends on the amount of thickness of hardening you want to get. So one other proposition in there was induction hardening. Then also the quenching process. Their current process is press quenching, and we looked into free quenching. Carburization, again, the part's put into the oven. This is a vacuum carburizer here. It's put into the oven in a carbon-rich environment. Carbon bonds to the exterior of the part. And then you have a hardened layer. Again, this process can take up to 8 hours.
Another group did the radiator. So when the radiator doing the thermal heat transfer, how efficiently they can do. They choose the alternative material and alternative manufacturing processes, and you will be able to see that part of their presentation, how great work they did for the radiator improvement in terms of sustainability.
Fully synthetic, there's no water or anything like that. They last a long time, but they're very expensive. So it might be prohibitive for a day-to-day car to use that, but in racing engines it might be a good option. Although water is one of the best coolants to use in an engine, it will boil at 212 degrees Fahrenheit, and that's usually not enough. To go through the engine, it could cause cavitation, which would overheat one specific part of the engine, and that will need additions like glycol or methanol to increase the boiling point.
The water would be the most, I guess, environment friendly.
Yeah.
And again, another project is shock absorber. In the shock absorber, how it can absorb the vibration, or it can work as a damper, and student did similar project, work talking to the working engineers and came up with different design and different shock absorber scenario.
Shock absorbers are designed to reduce vibrations in cars and make them more stable and balanced as you're driving on roads. So what they do basically is support the spring and suspension system, not holding the whole weight of the car, but just slowing the motion of the spring and suspension, so that movement is reduced in this shim stack, which has a few holes in it, which limits the amount of fluid that can go through, which changes the kinetic energy from the piston moving into thermal energy, which is distributed throughout the pneumatic fluid in the cylinder.
In terms of the dashboard, the group work with the local automotive team, and they came up with that when you have the dashboard, how they can better manufacturing or better injection molding or better design, and as part of the manufacturing processes.
Demonstration of the fabrication process for the coconut fiber. So first you have the nut harvesting, the husk separation, extrusion, steam explosion, and milling. And afterwards you have the hot pressing, and you can form it into a board or the 3D molded parts.
Then the door panel. Part of the door panel, student came up with the idea that how they can reduce the weight. So they came up with the idea that they would like to use the carbon fiber as part of the door panel. That's why they can reduce the weight, but still they can be almost substitute to the in terms of the resistance or in terms of the strength they can see, but it will be a little bit costly. So that kind of comparative study they did part of the door panel.
We decided really to focus on the hard layer. We came up with some alternatives. Carbon fiber, it's a very strong light material. It's become very popular in recent years. Fiberglass, it's been used for a long time, but it has good surface finish and strong, but it has a couple of problems I'll get used to in a bit. And hemp fiber, it's a natural fiber, it's biodegradable. It's used in the UK, but we don't produce it here. I'll get to that in a bit. And then steel, it's more environmentally friendly than most plastics, but as you'll see, it's not necessarily the best choice. Okay.
And similar to the door panel, another student group did the instrumentation panel. In the instrumentation panel, how they did the redesign and how they can accommodate the whole thing together with cost-effective manner as well as the visual imperative. So that's why they can address the environmental issue as well as the greater societal issue.
If possible, switch to a cheaper material such as PVC. Although it is less accurate, it is still rigid and has the chemical resistance and no conductivity like most plastics do. And if possible, with the process, switch it to thermoforming, because that can be a lot cheaper. And the design itself right now is pretty good, but if possible, you can make it accommodate, or you can have it accommodate to that material or the process. But in the end, what they have now with polypropylene with injection molding, it's probably optimal as it is right now.
In terms of the car bumper also used for the protection, for vehicle collision, all those things, but it carry heavy weight. So how can we reduce the weight? So they came up with different kind of techniques so they can increase the life of the bumper as well as the manufacturing and alternative material process for recyclability.
Our optimal design recommendations is, again, steel for the reinforcement beam, and for the manufacturing processes we chose hot stamped. This is basically the sustainability portion of it. So the hot stamping portion of it, this is how many will be produced in 2015. And the steel is also expected to rise in 2016.
Students need those similar kind of project, and that could greatly affect our environment, greatly affect our societal aspect. So that is the main purpose of this keen sustainability project for product design and manufacturing. And ultimately, it was a great learning for the student going through the design, going through the manufacturing, how it could affect the environment, how it could affect the cost, and what is the life of the product cycle all together. And it was a great experience for all the students, as well as it was a showcase so they can present part of their group project.
This experience was very, very important in that it offered an opportunity for other Keene schools to use this material in their classes. And we're hoping that as a result of this model, it will be replicated throughout the entire system of schools. Thank you.